Hey, it's a great day in Hurst, Texas, and I know you think you're looking at a red car right here, but it's not red, it's really black. It's just that hot in Texas right now. Special shout out and thanks to Freeman Toyota, and also I'm rocking the logo right here. Bill Kids Toyota last week hooked me up with a brand new shirt, and I'd like to shout out to those guys. Thank you guys so much. This is an issue of PK52. Today's topic, Star Safety System. Star Safety System, the foundation of safety for Toyota. Let's start with the ABS system. We have a 4-channel ABS system. That means that each one of the wheels has its own actuator and works independently. There's other manufacturers that have a 3-channel system, and some have had a 1-channel system, and this is where the 2 wheels would act together. Let me give you an example of why 4-channel is so really good, especially in the wintertime driving situations. You're driving on snow and ice, and somebody forces you off the road. They just didn't see you in their blind spot because they didn't have a blind spot monitor, and now your 2 passenger tires are off the road. When you hammer the brakes, those tires are going to start to lock up because they're on the snow and the slush. ABS will pulsate the wheels. The cool thing about it is these 2 wheels are still on the dry asphalt, and they're stopping at maximum capacity. So what it does is it decreases the stopping distance. Tie ABS into EBD, brake assist, traction control, and VSC, then you have a great ABS package. Let's talk next about traction control. After ABS, we'll move to traction control. And really, just to clear everything up, traction control is kind of a trick. In a Camry like this, it's a front-wheel drive car. The front differential allows the wheels to turn at different rate under power, so you can steer and add power to the car without wearing the tires out. That was kind of the biggest play when we went to front-wheel drive cars. The problem is the differential will always put power to the slipping wheel. So if you over-accelerated a tire and this one started spinning, then power would come to this wheel. We call that a one-tire fire. So what we want to do is we want to fix that. A lot of people say there's 2 things that happen with Toyota's traction control. There's throttle kill and the use of ABS. Let's talk about throttle kill for a second. It's not throttle kill, it's throttle reduction. Let's say you're driving on dry asphalt, and the reason the tire would ever slip is because you over-accelerate. So once you spin the tire, the differential would put the power to the tire that spun. The throttle realizes that you've over-accelerated and would reduce the throttle to the adhesiveness of the road. Let me explain. Today the road is real adhesive, it's a 9 out of 10. So throttle would be killed to a 9. The next day you're driving, it's rainy outside, and the same acceleration spins the tire, and now the road adhesiveness is a 5. Well, the throttle would be killed to a 5. So it's just enough throttle reduction to match the road surface. As you start to go, well, then you start to move, then it would rise up 5, 6, 7. Again, it would mirror that. But watch this. If the road was really slick and the tire was going to spin, then the ABS applied by the computer to this tire would stop rotation. This may sound crazy, but brakes can actually slow wheel rotation. So once this wheel slowed down slower than the opposing wheel, the differential would send power over there. And then it would send power back, send power over there, so move it laterally across the axle. So, and the throttle kill, until you got enough momentum to be able to move the car. Toyota's traction control works from 0 to infinity. Well, let's say here's the story. Last night I went out with the Bill Kids basketball team, the community basketball team, and I blew my knee up. I don't know why at my age I'm out there running with the young guys, but here it is. Is there something in a Toyota that makes me a safe driver? First of all, let's be honest. You can't flex your knee. Why are you driving a car? But Toyota puts brake assist in the car. Let's say I'm driving down the highway and somebody runs a red light or runs a stop sign. I can't really bend my knee to get to the brake pedal, so there's no way I'm going to be able to hit that brake pedal at 100% and drive it to the floor. Brake assist realizes that I attacked the brake pedal in a panic or rapid strike. and immediately it magnifies the brake prowess to 100%. So even on this day, when I blew that knee out and that knee is swollen and sore, I'm still a safe driver. Brake assist makes you a better driver. I've loaded everybody in the car. We're going out for the day, maybe to the park, maybe to the beach, or maybe we're taking a trip up in the mountains to go snowboarding, but there's a lot of weight in the car. So how does electronic brake force distribution know that there's weight in the car? As I'm driving to work every day, it measures the weight of the car by the size and rotation of the wheel speed. When I add 5 passengers in there, so me and 4 others, then the weight goes up. I need more throttle to move the car, and the wheels are squashed so the RPM goes up. So it can actually tell where the weight has been placed in the car and move the brake prowess from front to rear. If I go hard to the brake pedal, then immediately brake assist and brake force distribution are going to move the brake to the front wheels because that's where the load's going. But the coolest thing about this is it works with a lateral G sensor, lateral gravitational sensor. The more I turn the car to the left, the more everybody moves to the right. Harder left turn, more roll to the right. So if I'm turning the car and I hammer the brakes, that's the worst place to put the brakes on. But the lateral gravitational sensor will move the braking prowess to the outside where the load is to make you safer in a straight line stop or slowing the car down or stopping in a curve. Electronic brake force distribution is the brake system that can think. Every car manufacturer now is adding stability control. Toyota calls it vehicle stability control, and with the Camry, with the electric power steering, we call it enhanced VSC. So it reacts quicker. So some of the things that we want to understand about vehicle stability control is it corrects oversteer and understeer. Oversteer is when I turn the wheel and the car goes straight. Oversteer is where the rear end tries to pass the front end. Let me say that again. Understeer is when the car is pushing, I'm turning, but it's still going straight. Oversteer is where the rear end is trying to pass the front end. So, how does the car know? Well, where I point the steering wheel is where the car is going to go. So I guess what we've been saying, corrects oversteer and understeer, really is not the truth. The truth is, where you point the steering wheel is where the car is going to try to go. So steering wheel position sensor. And remember, if you're making a sweeping left-hand turn, then the inside wheel here is going to travel the shortest distance, and the outside wheel over here is going to travel the longest distance. That math right there lets the computer know that we're in that left-hand turn. Next, roll rate and yaw rate sensors. Now, in an understeer situation, the more I turn the steering wheel, the more roll I'm going to get to the outside. So it's kind of roll to the outside, roll to the outside. So it measures that roll of the car and understands the dynamics of the turn. In yaw rate is where the rear end tries to pass the front end. It's kind of like this, where some of y'all like that, some of y'all don't. Yaw rate. So I've got the roll and yaw rate sensor, and then the throttle position sensor. In an understeer situation, it's probably because the driver was driving too fast when they exited a ramp or tried to make the turn. So what happens is it measures where your foot is in the throttle. So it looks at all of these things and says, hey man, there's a problem going on. I've got to turn the only thing off in the car not working, which is the driver. And the ETCSI, which is the electronic throttle control system with intelligence, shuts the throttle down. Listen, here's what it sounds like in a Prius. See? Hope I made you laugh right there. So it slows the car down, I make the turn. And then the ABS is controlled by the computer. Think about this. It can brake one or multiple wheels. Kind of like a zero-turn lawnmower where you use the brakes to turn. And it hooks the car to where you're pointing the steering wheel. If you take a moment and make your customer understand exactly how stability control works and how we've enhanced it, it magnifies the presentation. Vehicle stability control. Finalizing PK52 Star Safety System on location in Hurst, Texas. Again, a shout out to the Bill Kids guys. Listen, Smart Stop. It's very simple. We don't ever want a throttle situation like we had in 2010, whether the media talked about it and made it bigger than it was, or whether there was really a throttle pedal that got entrapped by a floor mat, which can happen. If the throttle can't come back, that's a big problem. So what Toyota's done is they put smart stop technology in. So if the throttle is open and you go rapid to the brake, the computer immediately knows, hey, that shouldn't have happened. So it throttles the car down to idle. So again, if the throttle's open and I go hard to the brake, the computer realizes what's going on and throttle is cut to idle. Star's safety system. That's our base of the safety we put in Toyota. Magnify that, make the customer understand it, and have a good time with them when you explain it. This has been Star Safety, PK52.